Unity overcame all pandemic conditions and reached our hospital in January 2021. After the hard work of elected engineers, the constructions of radiofrequency cage began and took place in April and took about a month. When the device got its general appearance, the device acceptance test called that took place in May. After the intensive MRI and the physics training, which lasted from the end of May until the patient admission, the necessary documents were obtained and first patient took place in July. I have that this in here, you know, this is a new machine. When you meet for the first time this machine, please don't be scared. Especially physics team, electrophysics team is with you throughout the whole process, so you are not alone. Unity is just a linear accelerator with integrated 1.5 Tesla MRI functionality, and it has 7 MV flattening filter free, SAD 143.5 cm, maximum field size for cross-plane 57.2, for in-plane 22 cm. Unity's head design is same in conventional ones, and it's called agility hat. I think everybody knows in the room the agility hat. It has the same design, which means it has auto-tracking, virtual lifts, and it has 160 lifts. As you may know, there is no table and collimator rotation in the device. The table moves only longitudinal direction. There is no left and right and up and down. And also the maximum gantry speed is 6 RPM. So the device can perform 6 rotations in a minute. Here is a video showing the speed. What is the benefit of this? Sometimes you make a plan like a VMAT plan. You need plenty of AMRT fields to do that. If you are plan like this way, the machine gives these transaction areas very quickly. So the treatment time, I mean beam on and beam off, will reduce due to this speed. When you enter this room, first you see the pearl white cover with radiofrequency cage underneath it. In the treatment room, there is a mosaic patient interface, an anterior coil to take MRI scan, one posterior coil. It is integrated into the table. We remove this posterior coil when we are doing the physics measurements to avoid any damage. A 1.5 Tesla MR is placed within gantry center. Of course, there is a magnetron, and magnetron generates RF waves required for the waveguides. Waveguides are different comparing to conventional one. Conventional use a traveling waveguide, but standing waveguide is used in Unity. Since there is an MRI area, all the staff and all the patient needs to be MRI compatible because the magnet is always on. It is never off. So because of that, we use a metal detector in our clinic to prevent any accidents. We generally use T2 3D MR sequence for the treatment and for the simulation. Thanks to motion monitoring while the patient is irradiated, we can instantly see the image of the patient during the radiotherapy. Recently, Elekta got CE marks automatic gating functionalities with motion management, which means soon gating techniques also be added. We also frequently use in our clinic a DWI sequence, aka diffusion-weighted imaging. With DWI, we can predict the response to the tumor of the radiotherapy. We use this sequence at the beginning, day of the treatment, once a week, and the last day of the treatment. So, how to understand tumor response with DWI? DWI gives us ADC values. ADC, which means apparent diffusion coefficient. ADC is a measure of water molecule within the tissue. As the tumor responded, the water fills the begin the tumor. So ADC value increases. Here is an example. This is the first day of the patient. We take DWI sequence and it gives a ADC value. This ADC value is 1.027 and the last week of the ADC value is 1.236, which means ADC increased the tumor responders. Thanks to DWI and ADC value, we can predict the response of the tumor to radiotherapy, so we can change our radiotherapy plan according to tumor's response. We also frequently use 3D vein sequence in our clinic, especially for lung, abdominal region, liver area that change with breathing. You can liken this to 3-slow CT technique. We perform CT, 3-slow CT technique from the CT. At the same time, 3D vein sequence from the MR simulation. We fusion them in offline monoco after our doctors give the delineation for ITV. You can see the difference between 3D vein sequence and CT imaging in lung cancer. Unity use 1.5 superconducting magnet. The features of superconducting magnet is they can only work at liquid helium degrees. In this system, the magnet is formed by the intertwining of many structures called cryostats and is located in the structure and that contains liquid helium cryogens. And this cryostat is very homogeneous. The radiation beam passes through helium-filled cryostats and the helium-filled cryostats with the average energy of X-ray beam increases. This physical effect called beam hardening. Due to this kind of physical effects, the cryostat divided into two structures, and this structure called annulus. Thanks to this system, the radiation beam is not completely absorbed by the cryostat during the treatments because of this is the MR and ME imaging test. For daily test, we use head phantom. We can do with this phantom float field uniformity, signal to noise ratio, spatial linearity, and more at the same time. And it takes only 15 minutes. We also check weekly helium level degree. Our helium level says, and due to magnetic field, all the electronics are shielded. With MD imaging system, we can check MRME isocenter check, ion chamber location with water phantom, isocenter determination while receiving the output, and more. During the installation process of the device, the MR mechanical isocenter is within 0.5 mm of the Gantry isocenter. After the device assembled, the MRME compatibility checked by the MRME phantom. A T1 weighted MR image is taken from the MR system, and the 10 Gantry angle of image is taken with the ME imaging system, and then we fusion them. After that, we send these images to the program. It's called DPPC, and we analyze them. Our monthly measurement